Well, good evening, everyone. It's Tim, your living sky guy from the Paris of the Prairies, beautiful Saskatoon. And first off, I want to start off by saying I wish I was on the prairies right now. As you can see, I'm inside my home. My plan was to be out at the Sleaford Observatory and be out under the open skies to be able to not only talk about the things we're going to talk about tonight, but actually visually show you them. Have you have a chance to peek through the telescope. But the problem with astronomy is a hobby that is entirely dependent on the weather. And as of about 2 hours ago, the weather forecast for Sleaford was 89 with 14 degrees Celsius and a whole lot of wind, about 35 to 40 kilometer an hour winds. So I had to make a decision that no, that's not going to happen out there this time. But I promised you I'd be here to talk about some stuff, and that was only going to be part of what we were going to talk about, was actually let you look through the telescope. But instead, let's just dig into the subject matter again. Now, first off, what I'd like to say is this is, as you know, streaming on 3 different platforms right now. So in theory, if you're on YouTube or on Twitter or on Facebook, you should be seeing it all at the same time. So consequently, since I'm literally a one-man band, me and a camera and a switcher box and an iPad, I cannot keep an eye on what's going on any of the questions that are coming up. But if you do have some questions, please put them in the comments. I won't be able to get to them while I'm doing this live, but I will take a look at your questions and answer them to the best of my ability afterwards. So, what are we going to talk about tonight? I want to talk about a few things. I want to talk about what's happening in the July sky. I want to talk about, first off, the 4 easily visible planets that are out there for the month of July and beyond. And of course, I want to give you a bit of an update on Comet Neowise, which is kind of the hot topic in astronomy everywhere right now. To Neowise, let's start with what's happening right now with the planets. And as I say, we've got 4 very easily visible planets right now in our evening and early morning skies, starting with the 2 biggest ones. The first one I want to talk about is Jupiter. And tonight's a very special night for Jupiter. What's so special about tonight? Tonight is what's known as Jupiter's opposition. And opposition just means that the orbit of Jupiter and the orbit of Earth are bringing them into a position where they are right now closest for the year. Okay, so at this point they're at their closest approach. So what does that mean to us? No, we're not going to bump into them where they're long distance away. But what it does mean is Jupiter is right now incredibly prominent in our southern skies. If you're anywhere where the skies are clear right now, which I'm not, you will find Jupiter hanging out sort of low on the horizon, but definitely giving you a really prominent view of it. And to give you an idea what that looks like, let's just switch over here. Okay, so we're in Stellarium, and let's zoom in a little bit here. This is right now, at the time, if I was standing outside right now, this is where we're going to see, as you can see in the center of the screen, there's our southern sky. And just over in the southern sky, you're going to see the very brightest star, or star-like item you're going to see there, will be the planet Jupiter. And right nearby it, and as you can see just a little bit over to the left, as in to the east and slightly lower, is the next brighter star, which is the planet Saturn. So as I say, tonight Jupiter is in opposition. So it's at its closest approach to us right now. Now the nice thing about that is this Saturn's going to be pulling the same trick fairly shortly. We'll talk about that a little bit in a little while. So that's where Saturn is right now in conjunction. If you look, we've got south on the left-hand side, you got right-hand side, east on the left-hand side. So just a little bit south-southeast is where you're going to see Jupiter hanging out. Now, to the naked eye, it looks just like a bright star. So let's say you want to have a closer look at it. One way to have a closer look at it is to look at it through a pair of binoculars. And if you're just getting started in astronomy, binoculars are really the best route to go. And for binoculars, I always recommend either a 7 by 50 or a 10 by 50 binocular. They're ones that give you good light gathering capability, but not too high of a magnification to make it too difficult to hold them steady, and also still keep the brightness up. You can get more power. I not recommend that though. The narrower your field of view is, the harder it is to find things, and a higher magnification gets you into too narrow a field of view. The other thing is, you're not only magnifying what you're looking at 10 times, but you're magnifying any of the movement of what you're looking at 10 times. So that means when you're holding the binoculars, and if you're magnifying 10 times and you're moving a little bit, that movement is magnified 10 times. So definitely you don't want too high of a magnification. A 7 or a 10 by 50 is a good option. So let's say what happens if we point our 7 or 10 by 50 binoculars at Jupiter. Well, what can you expect to see? What you can expect to see is roughly something that looks about like this. Okay, so what you're looking at there, I'm just going to zoom it in just ever so slightly. So what Jupiter is going to look like to you is a bit more of a disk. It's not going to be a pinpoint star. There's actually going to be a defined looking disk. But the other sides of it, you will notice that there will be little pinpoint lights. Those pinpoint lights are the Galilean moons of Jupiter. Jupiter has a large number of moons, but 4 of them are named the Galilean moons, named after Galilei, who first noticed them, who first visually saw them through his first telescope. Particular moons, depending on where their orbit is, where their position is in their orbit, sometimes you'll see only 2 of them, because maybe one of them is going to be behind Jupiter, or 2 of them are behind, or one's in front and one's behind. But sometimes you'll see 3, or sometimes you'll see up to 4. So for example, this evening, as you can see, we can see 3 of those Galilean moons. Now what's unique about the Galilean moons is not only do they show up as those little pinpoint light sources, but also what happens with them, I'm just going to pause this so it doesn't move out of our frame. What also happens with them is you can actually see them change position throughout the evening. You're looking at something millions of miles away, but they're orbiting at such a speed that we can actually see them move in their orbit. Just to give you an idea, for example, let's just center Jupiter on here, 1 second here. Okay, let's see if this is going to let me do it here. Okay, as I'm speeding up the time, as you can see the clock's moving, you'll notice how those moons are actually shifting. In fact, Io at 2 o'clock in the morning or 3 o'clock in the morning will actually come out from behind Jupiter. So it's actually changing position as the evening is changing. So you have a chance not only to see this planet, but you also have a chance to see their moons actually moving just throughout the evening, which is really kind of fascinating when you think about it. Okay, so binoculars, like I say, the view you're going to get from binoculars, let's just pause this, come back here. Okay, so through binoculars, this is roughly what you'd expect to see. So that's what binoculars will let you see. If you turn a telescope to it, and that's where you're going to see a little bit more definition. So for example, if I take a look roughly here, this would be what you'd expect to see if you had a telescope with roughly about 40 times magnification. Now, the one thing when you're looking at a telescope, do not focus intently on high magnifications. When you look at the kind of telescopes that you usually see in something like a Canadian Tire or a Walmart or something like that, they are usually, what I would refer to as the department store telescopes. They're usually pushing high magnification. You'll see in the box 475 times magnification, or 500 times magnification, or 425 times magnification. Well, what I will tell you is that type of magnification on like a $100 or $150 telescope is virtually useless. You're not going to be pushing it to that high magnification because it's just not going to look sharp. It's going to be frustrating to use. Don't go there. Lower magnification is always going to give you a better result when you're talking about those inexpensive scopes. So for example, you might have seen a post that I did recently showing a little telescope that I put on a shorter mount that I made to share with my grandchildren. That's just one of those department store type telescopes. But that one at 40 times magnification is a really nice usable scope. And at 40 times magnification, this is an example of the kind of view that I got of Jupiter. And what you'll see is if you've got an evening where the atmosphere is nice and still, there's not a lot of movement in the atmosphere, air currents, rising heat, that sort of stuff, you can start to see hints of the cloud bands on Jupiter. Jupiter itself is, when you look at it much closer, like this, you'll see it is literally covered with clouds. And those clouds are going to band around the equator as those clouds are essentially rotating around it. On a better quality telescope with higher magnification, you could expect to see, something like that kind of a view. When you're talking about something like say a 12-inch Dobsonian with running at 150 power, that's the kind of thing you could see. But for your average department store telescope, take a look at it something like this. Expect that. And to be quite honest, that in itself is a beautiful thing to be able to look at a planet so far away from your backyard and see just that hint of those cloud bands is absolutely breathtaking. And the nice thing about viewing planets is you don't necessarily have to have incredibly dark skies. Planets themselves are quite bright. The visible planets are very bright, so you don't have to worry about getting out to a dark sky area, getting away from the light pollution of the city, because for the most part, they're quite easily accessible. So that's Jupiter. Okay, so what are we going to talk about next? We're going to talk about the neighbor to Jupiter, which, is Saturn. Okay, so here's Saturn, not too far away. That's our next great planet for the summer. And both Saturn and Jupiter are going to be visible in the night sky all night, all summer. Now, Saturn on July the 20th, that's in 6 days' time, will also be in opposition. So it's going to be at its closest point to the Earth. So we're going to see it at its brightest point, sort of ramping up from now until then. You won't see a lot of difference in the brightness between now and next week, but it's just more of a measuring stick, as in, yes, in that week's time, it's going to be at its closest. So what's Saturn going to look like if you point your binoculars at it? So you've got your 7 or 10 by 50 binoculars. What you can expect from Saturn when you go into that kind of magnification is something roughly akin to this. And what you're going to see is, instead of it being a round disc, it's going to look like a flattened disc, sort of a little flattened, almost like a donut type disc, as in a squished donut, or if you took a donut and turned it on its side a bit. So what you're looking at there is that flattening, that sort of oval.
I couldn't hear.
Shut up, Siri. That oval is essentially it's being created essentially by the rings. So that's what you're going to see with binoculars. Now take your department store telescope at 40 times magnification, and you're going to turn your view into something like this. Let's see if we can get those labels the heck out of the way. Okay, there we are. So what you're going to see is something more like this, where it's still going to look like a disc, but you're going to see a little bit more detail in the fact that there are rings, and you'll actually see a separation between the rings and the planet itself. So a little bit of negative space in between. And then of course, if you go to really high magnification, that 150 times power on a Dobsonian, on a 12-inch Dobsonian, you can expect something like that. So Saturn, great little planet that's happening. And as well, as you can see, it's got a bunch of little pinpoint lights around it, which are its moons, or some of its moons, some of its brighter moons. Now, you're not going to see those with binoculars. You're probably not going to see them with your department store telescope. You may have a chance of seeing them with a larger objective scope, something like a 12-inch Dobsonian, and at higher magnification. Don't expect to see those planets yourself. I'm sorry, those moons around the planet. Okay, so that's our first two planets, the ones that are in our southern sky. Okay, let's come back here. So the ones that are in the southern sky, and right now it's at, at this time of the day, at 11:51, sorry, one second, reset here. 23:16, so 11:16, that is, well, where'd we go here? East, 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 there we are. There they are in that southern sky. And just to show you what happens as the night progresses, we're just going to speed up the night here a little bit. And you can see how they're moving from the southeast to the south to the southwest. So let's take a look at what else is in there. Now the other planet we want to talk about is the planet Mars. So let's go over to the eastern sky. When we go to the eastern sky and we run our clock up a little bit, boom, just after midnight, you're going to see Mars, the red planet, popping up out of the eastern sky, almost straight east. So in this case, in Saskatchewan, that's at, like I say, 17 minutes after midnight. With that one, when you point your binoculars at them, what you're really going to see is a disk. It's not as large as Saturn or Jupiter. It is closer to us, but it's not a very large planet. So you're not so much going to see, you're going to see it appear a little bit more of a disk, but you're also going to see sort of a reddish tint to it. Mars being the red planet because of the iron in its soil. So you're going to see it standing out from the stars around it with that reddish color. And if you point that department store telescope to it, same thing, you're pretty much going to see, one second here, if you point your department store telescope at it, you're pretty much going to see a larger reddish disk. If you've got a much better quality telescope and higher magnification, you may actually start to see some of the polar caps, sort of the whiter areas on the top. But generally speaking, think of Mars as a target that's just going to be reddish. Okay, so the fourth planet I want to talk about is our new morning star. The morning star being the planet Venus, and we're going to see Venus rising in the northeastern sky. Let's turn our labels back on here. Okay, so Venus is going to show up in our northeastern sky, and it's going to be rising right about, boom, about 20 minutes after 4. So you're going to see in the, okay, here's our east, here's our northeastern sky, and there's Venus rising up in there. So just before sunrise, you're going to, about an hour before sunrise, you're going to start seeing Venus showing up. Now this one is another one that's, in this case, it's the closest neighbor to us. You point a pair of binoculars at it, and what you're going to see is, first off, let's just zoom it in a bit more. The first thing you're going to see with binoculars, once again, it's just going to look pretty much like a disk, a larger disk. But if you point a telescope to it, let's see if we can zoom in enough. Hang on here. What's going on here? Okay, come on. Okay, I'm not sure why it's not letting me zoom, but if you point a telescope to it, that 40 power binocular, that 40 power department store telescope, you're going to see it show up and in phases similar to the moon. It's going to be in a crescent shape because it's fairly close to the sun, but only part of it is being illuminated by the sun. So it's actually going to look like a little tiny moon in your telescope. So it's kind of cool to look at as well. So those are the 4 planets I want to talk about that we're going to be seeing all throughout the summer months and going into the fall. So we've got our big old Jupiter. Let's just zoom back out here again. So we've got Venus here. Hang on here. Yeah, that's where, okay, I was looking at the wrong thing. Here's Venus, dagnabbit. Okay, zooming in on Venus. Let's come in closer again. There we are. So this would be Venus essentially with your department store telescope, where it is giving you that little bit of a crescent moon effect happening. And with binoculars, think of it as something more just like that. You're not going to see that crescent shape unless you got really, really good eyesight. So going back to our summer planets once again as a recap, we got Venus. If your eyes are really good, and this time of year they'd have to be really good, you might pick up Mercury, but it's so close to the sun right now, it's not really showing up very well. Of course, we got our crescent moon that's happening right now in the eastern sky, and this is, as you can see, is about 4 o'clock in the morning. We've got Mars over here in the southeastern sky, and Saturn and Jupiter getting ready to set. So those are those 4 planets with that sort of bonus one of Mercury if you're lucky. Now, the one thing people always ask me is, well, how come they're always in a line? Well, that's called the ecliptic. And the ecliptic essentially is our solar system, essentially, the way our solar systems lay it out is it's on for the most part, a flat plane with all of the planets orbiting along that flat plane. A couple of them sort of are tilted a little bit, but for the most part, they're on that flat plane. And that flat plane basically is in the sky is known as the ecliptic. And the other thing that's unique about the ecliptic is there are a bunch of constellations. There are 12 constellations that hug the ecliptic. And those 12 constellations that are part of the ecliptic that are sort of around it are the zodiacal constellations. So those of you into astrology instead of astronomy, those are the signs of the zodiac based on those constellations that are always where the planets are. So when they talk about moon is in Capricorn, things like that, that's what they're talking about. The moon is actually in Capricorn, or the moon is in the 7th house, or whatever the heck the song was. I wasn't good at that. So anyways, that's what we're going to talk about there. The last thing I want to leave you with before I let you go, because I did say this was going to be 30 minutes, is Comet Neowise. If you saw my video about Neowise, that basically talked about Neowise was pretty much best to see in the early mornings, about 2 hours before sunrise. Well, of course, comets do move in their orbits as they're getting further from the sun. So what does that mean to us? Neowise has now become an all-night comet. So let's just switch over to here, to this view here. We're going to zoom back out again. So right now we're going to change our time back to right now, and we're going to go to, oh, sorry, let's turn that back on for you. So right now, being 11:25, Neowise is sitting, as you can see, I've got it sort of smack dab in the center. That's the label for Neowise, and it is right now just west of north. See, there's west, there's north. So it's sort of north-northwest right now. So it's going to be first visible when it gets dark. So right now, I would say for Saskatoon at our higher latitudes, it's going to be probably best visible starting at around about 11:45 to midnight. And then what's very cool about this is it stays visible throughout the night. I'm going to speed up the clock to show you what happens. See what happens to Neowise? It's now at about 10 degrees above the horizon when it's at the north. So it's giving you quite a lot of space across that horizon. And then as we're getting closer and closer to like 3 a.m., you see it's now coming up higher in the sky. And then it's going to get brighter and brighter. And I forgot to turn the brightness down. At 5 o'clock in the morning, you're not going to see anything at this point. But you can see how it moves in that west to east direction. Starting at when it's first visible, as you can see, the sun's setting right here at about 9:20 there. So sun goes down, give it a couple hours, it gets dark enough, and Neowise is moving across there. Now this is set right now for the latitude for Saskatoon, which is at 52 degrees. For the majority of Canada being Eastern Canada, BC, that sort of stuff, you're at 49 degrees. So you're at a lower latitude than us. So what does that mean is it's going to be lower in the sky, but not by much. When we're looking at it at its lowest, it's 10 degrees above. When you go to 49 degrees latitude, it's still 7 degrees above. Now, the easy way to be able to measure degrees, to give yourself an idea where to look for this comet, because initially with the naked eye, it's not as easy to see. But if you're looking for how high in the sky am I looking, if you make a fist, if you're living in the Saskatchewan, like Saskatoon area, 52 degrees, make a fist like this, hold straight up and down like this away from you, and the distance from here to here is approximately 10 degrees. So if I'm trying to spot what height is the comet going to be, I'm going to put this on the horizon and read up, and that's roughly going to be 10 degrees. If you are in British Columbia or Toronto and you're looking for that comet, it's roughly at about 7 degrees. So what's 7 degrees? Think of taking this part of your hand, those 4 fingers, and that's roughly about 6.5 degrees. So that's a good measuring stick to use. So what's the best way of trying to find it? Once you know roughly the height it's going to be, look with binoculars and scan from the northwest to the northeast until you see that comet. Right now the comet has a very pronounced tail that is easily visible with any kind of binoculars right now. Even if you had a small pair of little 7x28s or something like that. Ideally, 7x50s will give you better light gathering capability. But basically, once you've found the looked and found it in the sky with the binoculars, it makes it that much easier for you to be able to put the binoculars down and then see it with your naked eye. And yes, this is a naked eye comet in darker lighting situations. Some people are seeing it in cities. It depends on what the lighting's like where you are. So if you're in a city that has lots of lighting, try to get out to a park or somewhere away from lights that will be messing up your night vision. The more accustomed your eyes are to the lower lighting, the better your chance of being able to spot it. Now, the question I've been hearing a lot is, well, how long is it going to last? That is anyone's guess. A comet itself can last for days or months or weeks, depending on how big it is and how close it is to the sun, where it takes it in its orbit, that sort of stuff. For those of you who are around for Hale-Bopp, over 20 years ago, Hale-Bopp was an unusually bright comet that was actually in our skies for almost 2 months. For 8 weeks, it was just this beautiful show. Neowise has only been really visible for about the last month, and if we're lucky, it's going to make it to the end of this month. So my suggestion is, if you have a chance, take it early. Try to find it sooner than later. The longer you wait, the less bright it's going to be, because it's now moving towards the Earth but away from the sun. And the further it gets from the sun, the smaller and the less bright that tail is going to be. So those are some things to take a look at this January. Take a look at those 4 planets: Jupiter, Saturn, Mars, and Venus. Take a look for Comet Neowise. I wish I was able to turn a telescope to Jupiter right now and show you. That was what my plan was tonight, but unfortunately those planets are sitting way off in the clouds. Just before I started the broadcast, I did see that the northern skies above Saskatoon were looking good. So as soon as I'm done here, I'm going to take a drive out and see if I can't capture some more images of Neowise. But on that happy note, I want to thank you for spending 30 minutes of your evening with me. I apologize for it being so late, but I did want to show you some stuff, and we have to wait here till it gets dark, and unfortunately I couldn't show you anything. So any questions, please leave them in the comments. Anything I was doing wrong that I could do better next time, please leave that in the comments as well. Thank you very much for joining me, and take care, everyone. God bless. Keep safe, keep distant, and clear skies, everyone. So long.